Unit number one, it was giving us the first preview of what is digital security or the computer security or introduction to computer security. We had some examples to explain and to make you be aware of the relation of this digital security with our daily life, with our daily activities. Mainly, a small recap on what this unit has to give us as objectives. There are terminologies that we are going to define. You'll be aware of the basic terminologies that you has to recognize in relation to the digital security. Some challenges and issues whenever we talk to settle up security or digital security solution. From another side, there is a need behind of setting up digital security. It's just came in. And then actually we go step by step. At the end, we'll be having a preview, a small preview about the standardized certificates that you may go after whenever you finish this unit, or sorry, this book or this full courses, since we are following an international standard actually for this course. So whatever we are learning is standardized, and it is following a certificate that you can go after later on. You may find the exam online to pass it, but you have to be very successful in this course at in order to succeed in passing this exam, the certificate related to this CompTIA. So small recap actually. Just I'm not gonna explain all the details, but immediately I'm gonna just show you the examples of the issues and frauds we may live daily. We saw the phishing context. We saw. I believe that you are able to see this window now. Yeah. So we saw the phishing. This is a category of threat that you may live daily, and this is an example actually as per this interview. Sorry, as per this view. We are seeing social media application, but the URL is completely different. So this is a Doughty interface actually, and also the content of the page is not fully uh, correct. So we have to feel doubty about using this interface. We know this Facebook, but it's not the URL. It's not the recognized URL. So immediately we don't use such interface. This is actually a try of a trick to thieve your credentials. Another example, actually, we see it's a simple image opened in an image viewer, Microsoft on Windows. A very, very normal image. It's an image. That's it. Full stop. But the computer does not recognize what is an image. He recognizes that this is a file. And because of this, there is a threat that we have to be aware of, the injection. The computer understands the metadata only. If I open the same image, we open the same image using a notepad, not an image viewer, we will see something like this. This is the metadata that the computer understands to translate it into what we see, the view, the image. Can you read this thing? Actually, even if you can read, it's not something you can understand for sure. It does not have any meaning for us as humans. Yet, if you concentrate well, see here, see where I'm pointing now, in this area here. Ping 202.15.175.2. This is a command actually. This is a Windows-based command actually. This is a network command. We can understand it. Also, see what's written here. DDoS, actually, space attack. This is in English literally said actually. We can read it and execute it like it is. So there are things we may inject inside. This is an injection. Like we injected this command, we may inject other things. So don't expect that this is an image, so it's very safe. No, an image is a threat cause. Another kind of threat, which is related to databases, the SQL injection, normal username and password, like the wave username and password, whatever, very, very, very familiar to us. a field or a system that asks us to identify ourselves by giving username and a password. Is this username and password okay? A security level? Yes, absolutely true. But does it have any trouble to authenticate the users? Yes, absolutely. See the example here. So since we said it is related to database to SQL, so there have to be actually a command like this one governing those inputs. So if we write instead of the username something like this, what I'm writing right now, single apostrophe or one equal to one, then a command startup. What does means actually the if the استعمل هذا الرد لانضمام إلى مجموعة واتساب ألوف يا ألوف. This is not the time for sharing the group. Okay. Yes, this is good actually what you did, but later on, not now. The query that reads the username and password, it has some actually annotations to read the username. This is it, user ID, and the password. This is it, the password. The user ID actually it would be terminated, not Srinivas like that, like this one. If I type single quotation, then O one equal to one. So the single quotation, this one, will close this one. So let me just open my tool for annotation. Me too. Just give me a second. I'm not finding. Hello. So the single quotation that opened here has been closed here. So okay, no errors. And we are given O one equal to one. It is usually true. It is usually true. Then thus. It will be validated and the system will give us the next step, will pass us to the next step, which is actually sort of an injection, but related to databases. So let me come back. Actually, all of this we explained last class and it is recorded, so you can refer to that. The first definition we give related to the digital security is to secure what and where. Actually, you have to recognize the asset question of security, then after the framework utilized to settle up the security. So what is the asset? Whether it is a software, operating system, application, group of files, data, what is the thing to secure? Then where? Is it in a computer, in a laptop, on the internet, public platform, whatever? So what to secure and where to secure it. This is the first concern or the first definition we can give related to digital security. So as I was saying, securing what and where. Actually, if I say, for example, I'm going to secure my email. What is my email? Is it in my computer? No, it is somewhere in the public network. It is somewhere in a relay, an open relay. Actually, it is somewhere in a publicly, I may use the word exposed server on the internet that gives the email as a service. So also the networks and remote assess their question of security, not only standalone computers. So networks also there are questions of security. Computer networks we talk. And in the network here we have to protect the data, hardware network related devices, and also software, operating system or whatever. All of them they are question of security. Yes. So due to what we just presented now, actually, can we, if I'm talking about, for example, I'm going to secure my email box. I'm going to spend 2,000 riyals to spend, for example, I'm giving it just to bring your attention, just to bring your understanding. Uh, if I'm going to secure my email box and I'm going to spend this much money, 2,000, does my email value this money? Is my email box important that much in order to spend this much money? If the answer is yes, so yes, okay. And the rule, actually, let me talk about the rule. The rule is that we cannot spend money more than the value of the asset itself to secure it. Actually, I'm not going to spend money for security appliances and security solutions and security techniques applied by experts that values more than the asset itself. No, no, it's not. It's not feasible. These the rules. What the rule said actually. We have to prevent, yes, wiqaya, but not to spend as much money uh, to trespass or to bypass the value of the asset in question. This is a rule, but on real plane, may talk differently. Okay, so as the first summary, there is no fully secure system in the sense of we cannot secure a system fully by bringing the security out to the level of 100%. We give a full guarantee to the end user that the system is secured. No, we cannot do that. No, no. Because if we do, technically we can and it is feasible, yet the system would be isolated. And once the system is isolated, so not usable. Isolated, no. It's closed and cannot be utilized by anybody. This is 100% secure. It has no entry points and it has no data to be leaked. Isolated. So it is not usable. It's useless. So we cannot talk about a system which is not usable. It's useless. No, we cannot. We need the system that we can use. So it has to be exposed to the public with public interfaces and things like that. That's 100% and fully secure system is not usable and you cannot find it on real plane. Any questions here, please?
No, Mr. Complete.
Okay, great. So as you were saying, we cannot spend money more than the set question of security. So protection costs should not exceed the protected value. This is a rule, but as I said, this is actually a theoretical rule only. On real plane, we may talk differently. So this is the nature of the digital security, but there are exceptions. The first technical definition we see is what we are presenting now. There are actually measurements to say that the system is secured or the security is set up. There are measurements, there are constraints we have to value. In the sense of, if I ask you if the system we are utilizing now, this meet or whatever, we are sharing data, we are having this classroom, is it secure? There are actually tools that we have to go through, or steps we have to pass through them one by one in order to validate or to deny. To validate, yes, secure, or deny, no, it's not. The triad we are seeing in front of us, the digital actually defining one of the security measurements techniques, it validates some of the aspects that describes the setting question. If they are validated, so the security is set. If they are not validated, so the security is not set. Confidentiality, integrity, availability. Actually, this is a pillar triad that we have to refer to wherever we try to check up the security level related to an asset. Concerning the confidentiality, it is a context of avoid the disclosure of information by a non-authorized party to disclose data or resources by non-authorized parties. You are not allowed to open the system. So this is the confidentiality. Only authorized parties they are allowed to do so. This is confidentiality. What does it mean? It means actually the username password, it has to be actually given to you if you are allowed. The system has to work for you if you are allowed, and so on. Confidentiality. The integrity. Actually, it is a context of to avoid the data we communicated actually, in the sense of if I send you a message, you have to receive the same message. If I send you an exam paper, you have to receive the same exam paper with the same questions, no modifications. Integrity. We have to guarantee that the communicated data is integer, it's not modified, it has not been altered or deleted. This is the integrity. What A sends to B has to be valid, with the communication scenario only. Good. The third, the availability, it is a scenario of to make the system run in a way that, yes, it has to give access to, let's say, authorized parties upon time and in a proper way. It does not have to deny the access. The system in question or the asset in question, it has not to deny the access from the authorized parties. If you are an administrator, you have to access 24 hours, 7 days a week. It does not have to deny you from accessing. No. If it does so, the availability is not set. So the availability is that the set in question, we talk mainly about the system, to guarantee that proper access is given to proper parties. Any questions here, please? Okay, continue. The same scenario, just a simple example to make you understand what is that. Exam questions have to be actually hidden and cannot be shared with the students before the exam time. Confidentiality. We cannot share the exam questions before the exam time. This is confidentiality. The system has to guarantee that. Whatever the system we use, it has to guarantee that the exam questions cannot be shared before the exam time. Not even with 1 minute. No. It has to be sharp. Again, the question itself, if they are given to the students cannot modify the questions. They can answer but cannot modify the questions. This is the integrity. What we sent you, you have to receive it like it is. You cannot modify the questions themselves. This is integrity. The system has to guarantee that. So this is the integrity. If not, the integrity is not set. Means if the students can modify the questions, so the integrity is not respected. Regarding the availability, the exam questions also, they have to be available to students on time. So yes, they have to be actually seeing the exams on time. And also the schedule, your schedule, you were in a registration period, they have to be actually given to you from the beginning. So from now on, you have to have your schedule, your study schedule. It has to be available from the beginning to the system or by the system. Availability. We cannot give you the schedule at the end of the semester. No, it has to be given to you by the system at the beginning of the semester. Availability. Good. Party is responsible for building up the security. Now, whom are the components that they build the security actually? Whom are the when you're playing, actually, we are not learning the security of the digital security to recognize it. No, we are going to set it up. We're going to implement it and deploy it on real planes. So we have to set the security on different platforms or whatever. Whenever you build an information system, you have to secure it. So the question comes here: what are the tools, or whom are the elements responsible for building the security scenario? Is it me? Is it you? Whom? The security experts. Why they are classified to be experts? Why? Because the elements responsible for setting up the security, they are numerous. Actually summarized here into three groups. We talk about the technology itself. The technology itself. So to talk about the security setup or security scenario, security plan, you have to use the appropriate technology, whatever, regarding the programming languages, regarding the security appliances, security tools. Technology has to be the appropriate one. We don't say that there is a constraint that you have to use this or that. No, but depends on the scenario, the plane you are in, you have to use the appropriate technology. Then, then procedures and processes, they are responsible for securing the process somehow. So you have to use dedicated procedures to deploy a more secure process. Before letting you access, even after you give, for example, in the EDUA, if we take the example of the EDUA, even after you give the username and password and they are validated, correct username and correct password, still you have to authenticate yourself using, let's say, another second, let's say, authentication tool, maybe a call, maybe using a specific device, maybe a token, something like that. Maybe a one-time pass, a second security appliance or second security let's say factor. So it's a dedicated procedure for specifically for security. Thirdly, another element, which is the skills, the capability, the knowledge you have to deploy all of them, actually to use the appropriate tools. Who said that they are appropriate tools or technologies? Because you have the knowledge. Then to deploy second security appliance after the username and password authentication, let's say, who said that they are actually the best, or this is actually a good option for such system? Because you are having the skills. So people. Security is usually on top of an information system. Security, whatever the security is, whatever the concern of the security, it is on top of the services themselves. We find the services, they are on bottom of the process. We don't settle up the security before having the set or whatever. So if I have, for example, you are going to buy a laptop, new laptop, and then after you're going to buy an antivirus, Kaspersky, whatever. Laptop is 250 riyals. The Kaspersky is, let's say, 5 riyals. Okay, it's very cheap. Let's buy today. See what I'm gonna say now. Let's buy today the Kaspersky, which is 5 riyals only, and tomorrow I'm gonna buy the next week I'm gonna buy the laptop. No, it does not have to happen like that. No, then no. Security is on top of the service because the security, it is not one standard tool. Now we just, you have to have this conclusion in your head now based on what we saw so far. The security, it is to be customized based on the service to give. It is not standard to have to be adapted to and compatible to all information systems. No, no. It is based on the information system you have. You will see what are the security components you need. Usually we find the applications and the resources on bottom, and on top of that, whatever the security required, whether it is for a digital device, a standalone device, or a network, or whatever, or both, it depends. Usually the information is the question of security. So when we talk about security, to secure what? Usually we talk about information to secure. We are going to secure information. So the information is the question of security. So we have to secure this information. And this information, actually, it is governed by the CIA. To start the security, we have to settle the CIA IA, confidentiality, integrity, and availability components on top of this information. It has to be confidential, it has to be integer, not modified, and it has to be available on time. The information. Okay, this CIA set on this information, it gives us information that has to be communicated when needed. It gives us information stored on a hardware. It gives us information managed using a software. I repeat, the digital security is taken care of, it's tackling the information or the assets, the files, the resources, whatever the information in question. And to talk about this security, or this secure data, secure information, we have to see clearly the confidentiality is set, the integrity is set, and the availability is set, which gives us secure data that has to be communicated or can be communicated using communication channels, social media or whatever, and also gives us secure data that has to be stored on a hardware, hard disk or something like that, flash disk or whatever, and also gives us secure data that can be managed using software, whatever the software is. This managed, stored, communicated, secure data is controlled by a physical layer, which are the tools. Which are the tools here? The tools. Whatever the computer, the flash disk, the mobile, whatever the tools that they are actually managing the data itself or the secure data itself. Depends. And those tools that they govern and that they host the secure data, they are controlled by skilled parties, the persons, the people. Layer number two. Layer number two, people. And on top of that, security dedicated procedures and functions, policies and politics, they are on top of all. Layer number one. What you are allowed to do, what you are not allowed to do. Layer number, the first layer. Any questions, please? Exactly what I was saying right now. Okay. Next step. Constraints and challenges regarding the digital security. Those are actually a summary of challenges that we have to pass through and the security experts pass through whenever they talk about setting up a security solution on a framework. We'll explain them one by one. The challenges, they are actually constraints that they cause. Okay, that's great. We continue. The challenges, they are actually constraints that they cause the security not to be running as best as it has to be actually, and it causes obstacles for security experts from, and it forbids them from setting up the security solution as they expect and as it has to be. The speed of attack is the first one. You have to understand what is that, and based on that, you'll understand what is the challenge. The speed of attack actually it is a context of fast behavior happened that caused actually, I may say, freak. It caused damage. It caused catastrophe that caused data leakage or something like that due to the speed of behavior, speed of attack, as per the title itself. Those are examples that they caused actually numerous uh, data breaches. Even they caused actually money transfers in matter of minutes and seconds. So due to the speed of behavior, so uh, the speed of action, speed of doing the thing, it causes the problem. Okay, I just finished my job inside. I give you the example. I just finished my job inside the EDUA, I will leave it for 5 minutes and later on I'll come and I'll close it. Those 5 minutes they may cause actually a disaster if there is a virus in my computer or something like that. So the speed of attack, it is caused by available time frictions that the let's say attacker or virus or malware, the negative the doer can utilize to behave, can utilize to behave. It is a matter of uh, time constraint. You have to beat the time, no more, no less. Speed of attack. So here, actually, what conclusion we can conclude from this is that a security expert does not say, "I am expert, so I can do everything." No, you are expert, but still the time is not waiting for you. So you have to be beaten the time in whatever scenario you are in. If you let the thing end done, you are losing the time, and thus you are given the chance to the attackers to succeed. Will stop. As a conclusion to push us to understand, if we compare this graph, actually see actually since the year 1980 من 1980 until to the let's say the early 2000s, technologies it was very primitive. Technologies were very primitive. Means actually it is very small technology available in the market, and they are utilized by few people, and it's not actually spread like what we see today. Thus, the attacks they are very, let's say, limited, and techniques and tactics utilized to attack they are also limited. To make us feel the speed of attack, let's talk about the technology available today and compare to what it is available in 1980. Even us as a humans, we cannot count. Technology is available today. It is a true mess. It is a true complexity that we cannot, as a humans, we cannot actually delimit. And this mess, this complexity, imposes a speed problem. Does not say that I can do everything regarding all the technologies available today. No, you cannot. You, as a humans, you'll fail because the huge technology size can push you to a failure status. You'll not be able to finish all. The number is not small. And if you can actually recognize a big number of technology tools and techniques and technologies utilized for security, you'll miss so many also still. And thus, this causes a failure versus the speed of attack countermeasure. You cannot stop, you cannot block the speed of attack. So it is not you cannot, but at least you are in a struggle to stop such behavior. You'll not be able to do that easily due to the complexity only. Let's talk about the other security challenge, which is the sophistication of attacks. There are so numerous categories of malware and numerous types of malware. Talking about viruses, for example, actually, if I give you this graph here where the folders are, and I ask you what is the problem here, is there any issue versus those the folders here? Yes, the answer is yes. There are problems. A folder does not have extension. A file like this one, a Microsoft native zipped file, yes, it can have a dot extension, but a folder, no, no, no. It's not a folder. Does not have extension. Does not have extension. We know files, Word file or let's say media files, have an extension, but folders, no, they do not. Does means the techniques. Sorry, let me come back. Techniques utilized to deploy attacks. They are the technology itself. They are sophisticated enough to confuse you as a user and to confuse the security appliances set onto your computer. The sophisticated techniques and tactics utilized to trespass the security measurements, they are complex enough to make you fail. I'll stop at this level. I'll stop at this level. We continue here next class, inshallah. Do you have any questions, please? Okay, if you hear your name, please tell yes. If you hear your name, say yes. Stop the recording.